Every machine learning model learns by minimizing error. But what does that process actually look like? Imagine a landscape, a surface of hills and valleys, where every point is a possible set of parameters, and the height is how wrong the model is. Training a model means finding the lowest point in this landscape. Today we'll watch that search happen in 3 dimensions, using the algorithm at the heart of nearly all deep learning: gradient descent. Here is our loss surface. The 2 horizontal axes are the model's parameters, weight 1 and weight 2. The vertical axis is the loss, how wrong the model is for those particular weights. Our goal is simple to state. Find the values of weight 1 and weight 2 that push the loss as low as possible, the bottom of the deepest valley, marked here in green. At any point on the surface, the gradient is the direction of steepest ascent, the way straight uphill. It's a vector built from the partial derivatives of the loss with respect to each weight. If the gradient points uphill, then it's negative points downhill. That is the key insight. To reduce the loss, we take a step in the direction of the negative gradient, shown here in green. The update rule is this: new weights equal the old weights minus the learning rate times the gradient. We repeat it again and again, each step nudging us a little further downhill. Watch the ball descend. Step by step it follows the slope downward, settling into the valley, the point of minimum loss. That, in essence, is gradient descent. But the learning rate, that step size, matters enormously. Make it too small and training crawls. It takes hundreds of tiny steps just to inch toward the bottom. Make it too large and the ball overshoots the valley, bouncing back and forth across it, and it can even diverge, climbing out of control. The right learning rate strikes the balance. Fast enough to converge quickly, yet small enough to stay stable and actually reach the minimum. Real loss surfaces are not a single smooth bowl. They have local minima, valleys that are not the deepest, and saddle points, where the surface curves up in one direction and down in another. These can trap simple gradient descent. That's why modern optimizers like Momentum and Atom add extra tricks to escape them. But every one of them is built on this same foundation. So gradient descent is really just this. Stand on the loss surface, find the downhill direction, take a step, and repeat. Scale that up to millions of parameters, and it is how every neural network learns. Negative gradient, step, repeat. Subscribe for the next lecture, where we add momentum to this ball and watch it accelerate through the valley.